computer. Okay. So I will start directly with my presentation today. We are talking about grade 1 to 6. First of all, Mrs. Okay, okay. So I have to be clear that the content of the books from grade 1 till grade 6 that you have already comes with what we call additional or e-curriculum that will keep high standards in ICT for your students. And the one available till now, because it was a emergency or it was urgent to do it, is from grade 1 to 3. So if you go through your application or your digital platform, and hopefully you have all access to this platform later on, if you have any problem, we can discuss it. But just once you go inside this platform, you will see that you have a PDF that you can download, and even students will have access to, where we've integrated 3 main chapters, which are algorithm, coding, and Scratch. And we believe that starting from grade 1 in offering students those skills will generate or will lead to a new students or generation of students that understand more what is coding, how to strategically create a program, and how to interact with a robot or with a microcontroller to understand more what is IoT, to link it with the STEAM. So all those big titles are not really just big titles for nothing. They are directly related to what you are offering to your students. And I believe that this tight coordination between all of us, me as author, Mr. Muhammad and Darul Warraq as agent or representative in Saudi Arabia, and you as teachers and administration, of course, will lead to deliver the maximum that we can have from it. And this coordination will remove or will put aside all the questions and the remarks that you may have. And we are glad to do it. So this curriculum from 1 to 3 is updated with an additional curriculum. Grade 4, 5, 6, as you can see, it's already updated with all the tools that we have. And we will be delivering soon another extra curriculum for grade 4, 5, 6, to allow students to have more and more. I can read, and I believe we've sent you before this. We've added the Tinkercad for grade 4 and 5. We've offered a software where you can simulate missions for robotics in case students are teaching from home. Now, today we are going to focus on some point in the curriculum. I mean that, as you know, the book, there is a chapter where general information about hardware are exposed, and especially its relation to what we call data or information. We are not giving those topics or those skills to students in order just to know that a keyboard, what is a keyboard, or why a CPU is made, or the screen. It's not the issue. The issue is to link all those hardware with the circulation of information and to understand what is information and what is the role of each single component of hardware in a computer with the information, since later on students have to manipulate those information while working on a microbit microcontroller or a robot or any coding language. After this presentation of what we call the hardware and data science and how to manage data and the information with the hardware, we move to a big part, or a part where we teach them classic skills in Office, like Word, Excel, PowerPoint. And as you know, since you are using this before, hopefully, and if you there is new teachers for the first time, skills are really clear in the present in the book, how to offer let's say Excel or PowerPoint or other skills. Another big part, which is the cartoon drawing, and this is, we believe, it's a very, very important part, since it's in direct relation with the STEAM education. I mean, we are offering students a technique, a unique technique, how to, from geometrical shapes, how to draw objects, starting from simple objects to advanced objects. You can see them on the book. And from those geometrical forms, when we are ready to create any object, a face or a car or a recycle bin or any object that you imagine, okay, we are teaching the technique, and we are link this technique to apply it on the Paint program or any other program. So the first part is to make a resume. The first part is data science, hardware, and its relation to what we call circulation of information. Second part, Office. Third part is data cartoon drawing, excuse me, okay. Fourth part, it's coding with Scratch. And with the e-curriculum, students starting from grade 1 will be exposed to the software to master and to develop skills in how to code, how to create programs, games, animation, scenario of stories in Scratch. And meanwhile, they are developing skills in technology, how to use the looping, the variables, and other technique in coding. Okay, the other skill that we are developing is the microbit microcontroller, which is essential for grade 4, 5, 6, and we'll be talking about this. And finally, it's robotics and 3D design to create 3D objects using the Tinkercad software. So I will go back a little bit to the microcontroller microbit. I will be sharing my screen, and I will be sharing my screen, and I will be launching a program called the Make Code for Microbit, which is included in the your book. The aim or the idea or the goal of this software is to introduce students to this microcontroller. And really, I don't know if we've already conducted, or if any of the teachers, mashallah, you are 12, if any of those teachers already held with us a microcontroller session, but I will consider that maybe there is some new. That's why I have to explain that the microcontroller that we have, which is the microbit, is absolutely a must to be given for students starting in grade 4, since it will prepare students to understand more and more for the higher grades the microcontrollers in Arduino, and to understand that in each single electronic device, I repeat, in each single electronic device, there is a microcontroller, and this microcontroller has a one goal, is to control this component. I mean, the fridge, the air condition, the ventilator, a car, a lift, a washing machine, any kind of a electronic device, even the mobile phone, okay, are managed or led by a microcontroller. The microcontroller is a board which may differ from an object to another, and this board will accept input and output devices. I mean, I can link to this board all the sensors I can imagine, sensor for humidity, for temperature, for any kind of I can use in microcontrollers. And as output, I can link to this microcontroller a screen, a LED, a buzzer to produce sound, a motor or a pump to irrigate water, and any kind of output device. What is the difference? Because maybe some of you teach also grades 10, 11, 12, and you may, if you lead a research on internet, you will see that there is another microcontroller or many microcontrollers available, but especially there is what we call the Arduino microcontroller. What is the difference between the Arduino and the microbit? Just 1 second. I will come back to bring a microbit and a Arduino. Okay, sorry for interruption. So we are talking about this microcontroller microbit, which you see on the screen, and this one is the Arduino. And we are in process to deliver to Saudi Arabia some kits of microbit and Arduino. And Mr. Muhammad, remind me, please, once those hardware will arrive, to provide few of them to teachers in order to experiment how to deal with this hardware, since it's a must for all teachers with students when we will be back at school in a normal schedule for all levels, to start working projects using the hardware, not the virtual machine. So here we are in a temporary phase. I mean, since students now may attend the course from home, so they don't have access to this microcontroller or the Arduino. That's why we will be using a virtual on-screen microbit, but believe me that the logic and how to think, it will be the same by working on a virtual machine or a virtual. Hi, are you hearing me? Hello.
Yes, we are hearing.
Sorry. I don't know what's happened on my screen. Excuse me. So I thought the internet was cut off. So the logic of developing skills in coding and in programming is the same using a virtual simulator or the hardware. But of course, we agree all that when students will handle this product in hand, they will be it will be challenging for them in order to see that it's really hardware, and they will be starting developing STEAM project. They will be using this microcontroller to use it as in STEAM project. So I will continue by saying that we will be delivering some of those hardware for teachers in order to experiment in class with students once they are back. And this microcontroller, the advantage of using Arduino, microbit for lower grades instead of Arduino, that in this microbit you have built-in push button screen, and even there is sensors behind. So students will not be doing a electronic circuit, which is really difficult for to start with lower grades. But I believe that in grade 10, 11, 12, it will be more easy because it's related to the course in physics, the concept of electricity, resistors and wires and so on. So this microcontroller is a solution since it includes push button, screen and sensors. And what you will be doing with your students is to follow the scope and sequence of the books in order to start developing simple skills, starting with displaying messages or controlling the push button or measuring the temperature. And all those manipulation will lead one day, if you want your student to manipulate STEAM projects, so they can be doing it without no problem. The interface is simple. How to manipulate, it's really simple, and it's really exposed in your book. And mainly you can see also, I don't remember if we already uploaded videos on our digital platform. If not, we will be very, very soon. So students will select from the category basic or input or music or LED and so on. And they will be moving the block they want. Here, for example, I have my screen. I will write the letter, let's say, I don't know, the letter A. I will be making the letter A, for example. And as you can see, in few seconds, the simulator will play the letter A. If you want, for example, to show the icon heart, or to wait a 100 millisecond from one block to another, so students will start showing and seeing this animation. And slowly we will add the sounds, we will add music, we will add the manipulation on the push button. I will not go deeply in the explanation, since in the book really it's clear, unless you will ask later on for a what we say a specific zoom just for the microbit. But I believe this general presentation will give you an idea how much it's very important for students to make a manipulation or to know what are microcontrollers and to understand that we cannot lead a world with IoT, Internet of Things, without understanding and manipulating the microbit. So teaching microbits or microcontrollers, believe me, will be an added value for your school, since it's a high level of education that will be linked to, as we said before, artificial intelligence, STEAM, and IoT and other topics. So I will explain another issue, that this software, the microbit or the make code from Microsoft, is available offline, so students can download the software offline if they have window, or they can open it online. And in the digital resource, I will say again, they can find the links even to download or to open the online simulator. I will stop for like few minutes to see if you have specific questions regarding the microbit. I'm hearing you, please.
Hello, Mr. Wissam.
Yes.
About the microcontroller itself, we do not have it yet. So when you will provide us by the microcontroller?
Look, as I said before, we sent already through courier a set of microcontrollers, even microbit or Arduino, and we are waiting to arrive to Saudi Arabia just to deliver you for you as teacher in order to start experimenting this hardware. So expect an update from that.
Yes. So we can postpone teaching microcontroller till microbit till this microcontroller arrives.
From an educational point of view, no, since you have the microcontroller as a virtual simulator on your screen, and you believe that, and we believe that, working on the curriculum with your students in order to make them understand what is a push button, how to control the programming using the push button, the loop, the variables, all those skills are the same, even if you have a virtual or a hardware component. So in case you start now in grade 4, 5, teaching them the microbit, knowing that you can start with scratch. It's not necessary to start with microbit. Let us be clear. But in case you want to start, you can without any problem. And already we've done this with our students, with my students, when last year we were at home and they understand, and I started doing projects and without any problem. But of course, once you as teacher will have this component, you will feel more about this hardware.
Okay, thank you so much, Mr. Wissam. Thank you.
Okay. Any other question?
Mr. Wissam, Assalamu alaikum. This microcontroller bit actually works for all the platforms, Windows, Android, and iOS, if students have multiple devices at their home.
Yes, on the online, they go on the browser.
Okay. Okay, fine.
Okay.
Thank you.
But believe me, it's a challenge for all of us to integrate it in your curriculum, because it's new for them and for you, of course, and it will move teaching ICT from one level to another. And like this, you will be preparing your students for higher grade to understand what is or how to work with the Arduino, knowing that Arduino is used for projects at university level. So imagine your students, while finishing their studies at school, they will have this background, and we will be ready at any time in Zoom or the moment I will be visiting Riyadh in order to make those workshops live with you, to give you all what you need to be confident and to feel relaxed and assured with this technology. Other question regarding the microbit? It is clear? Okay.
Yes, sir. Yes.
Okay, so I was saying that the main issue or goal that you have to lead with your students is to explain them before going to make code and to start working with this software, to make them understand the word of microcontrollers, to give them examples, to show them some videos. I right now send the video tutorial for microcontroller to make them understand how important it is for them to know this technology. Okay. Till when we have time just to just organize this session? Can you tell me, please? Can somebody tell me for when we have time today with you? Hello, can you hear me? Hello.
Yes, we can hear you. What do you want? Actually, repeat, please.
Till when we have with you this this session? What time is reserved for this session for today? 1 hour, more, less?
They didn't mention actually how much. They just mentioned that it starts at 12.
Okay, but you as teacher, your schedule, you have to leave at what time, or you have classes? I don't know.
Yeah, we have to leave at 1:30, and the other classes from grade 1 to 6, the lessons starts at 3:30.
Yani, we have like 40 minutes more or less. If we need, just we can continue, no problem.
Yeah, I think for the ones who hear.
Okay. So
hi, I want to say this thing that yesterday meeting we mentioned that this workshop will be from 12 o'clock till 1:30.
Till 1:30.
Yeah, till 1:30.
Okay,
today.
okay. Sorry.
Okay.
Sorry. Okay. So I will go now to open the website. I hope you are seeing the Tinkercad website. It will be opening in few seconds. So this account or this website is available for free to all the students. All they have to do is to sign in, and they will choose, even if they are working on Gmail, they will choose a Google account, or they will create a new email. And once done, they can join. Sorry, just 1 second. Sign in as Google. Okay, I've already have my account. I will be going through, right. You are using Google as platform at school?
Yes.
Ah, great. So each student already have his email, no?
In middle and high school, yes.
Good.
But elementary, of course,
4, 5, 6.
they are working. Actually, they are studying from home, so we are not confirm about it.
But
Like
they
from
have.
1 to 6. The parents, I think mostly students are using parents' account, Gmail.
Ah, okay, great.
Yeah.
So here in Tinkercad, what we can do actually with our students, it's another solution for online or at school teaching. Actually, we can create, we can do 3 topics, develop 3 topics. The first one is to create normal 3D design objects, and all we know how much it's important for students to start thinking about the concept of constructing 3D building and its relation with calculation, geometry, and math, and creativity. We can go through circuits in order to create a circuit using or Tinkercad, or Arduino or microbit, which is another solution also for that. And the third one is what we call the make code, the code blocks manipulation, and which is how to create a Scratch program. And this Scratch program will lead to create what we call a 3D construction. I mean, you will create the loop, the blocks, and so on. And after that, just 1 second to see if I can take another. Okay, I will take the table. Okay, great. So look here. Of course, maybe what I'm showing you is a little bit advanced, not too much, but we will be adapting the level to grade 4, 5, 6. But imagine all those blocks in Tinkercad, like Scratch, will lead by clicking on the play button to create automatically what we call a table. So I believe you can imagine how much is important to link coding algorithm with creation, math, and creativity to start drawing those objects. So I was saying that this will come later on with the extra curriculum. I was saying that in 3D, you can manually create your form without using coding. I mean, you have to move each block alone. For example, here, let's say you take the block that you want, okay? By clicking on the object, you can change the elevation, or by typing here the values. So you can change all the properties of this block, and you will start building block by block your 3D concept. And the third manipulation will be, just 1 second. Circuit. This is what we are trying to show you in order to link the make code with microbit with what Tinkercad offers. So the page will open. Okay, and as you can see here, you can select from the components the Arduino circuit. Sorry, the microbit, excuse me, the microbit. Okay, you can select, let's say, all the blocks. Just 1 second to search. Here is the microcontroller. You can take it like the make code, okay? And by clicking on the code, you can start building the project like in make code. You will ask me, what is the difference between make code and the Tinkercad? The difference is simple. In make code, you cannot add electronic devices and components like an external LED. Okay, you can manipulate only the board, but in Tinkercad, okay, you can just 1 second, please. You can let's say take a LED, this one, okay, and you can link it to the external pins, like here. I did a mistake, sorry, excuse me. Okay, and once this external LED is linked to the microbit, I can go here to the coding section, okay, and select. I have to remember, since it's for 2 months I did not work on the software, so digital write pin, I link it to 2 high, then digital 2 low to make it off, and from the basic control I will put a block of wait 1 second. I will click on the start simulation, and as you can see, the LED will start blinking. I don't know if you can feel what I'm feeling right now. So you are trying to expose your students to a new field of ICT and programming linked to electronics and linked to the concept of design, okay? Sure. And here I will send you a direct message that once we arrive to microbit and you did what's inside your curriculum in grade 4, 5, 6, which are in make code, okay, we can lead another workshop dedicated only for, like, for 1 hour, 1 hour and a half, dedicated only for how to manage and to work with the microbit using Tinkercad. And here the option of adding electronic components like the LED, like the resistors or the push button or the buzzer will be, believe me, an amazing part. You will adore it, you will love it, and even your students will be excited for that. And since this application is free and it's open for public, I mean, you don't have to pay. Students can open it at home, so they can explore it alone with their parents and show their parents what they are doing with your student. And I believe it will be a free advertisement for the school. Okay, so what I've tried to show you now, that you have to start working with the microbit using the curriculum ICT, the book you have, using the make code software. And once done, maybe not for this year, since you are implementing the new curriculum with grade 4, 5, 6, but for sure for next year, you will be using Tinkercad for microbit to add additional components as I've showed you right now. And here you can start asking students, how to add 2 LEDs or 3 LEDs, and to start make them blinking in a different ways. So here you have to mix electronic skills, simple electronic skills, with coding skills and design skills. Okay, so I consider that this part of microbit is enough to start with. Staying available, if you feel that you need more on microbit, we can do it at any time. We can go through each lesson to show you topic by topic and lesson by lesson the skills you have, but I believe it's really clear in the book. So now you have this introduction. You can go through it, and any question you have, you can send me a WhatsApp. Excuse me if you sent me yesterday a WhatsApp and I didn't reply till now, since I have we've sent a broadcast for all the teachers to ask them to register to the platform, and we received yesterday too many requests on my phone. Today I will answer all the teachers. They send questions and any help they want. I will be moving. Yes.
I have a question, Mr. Wassam, but not related to microbit, because this one I have worked on it, and it's really very interesting, and the student enjoy a lot, and it's easy to learn and easy to teach. My question is related to robotics, because I have done the project with my student making the robot, but do we have like same code? We can make a code and the robot will act according to the code, like here as you demonstrate.
Yes, we have a software which is
okay,
which is the make code for Lego. I'm launching it right now, where students, you can see it, no? Can you see it?
Yeah.
Okay. Where students will go through, and this is it was planned to start with this part actually, to explain you how to manage robotics. Let us be clear. And since this presentation is recorded, you can go back to it anytime you want. In robotics, you have 3 sections to teach your students about, or to learn your students about. The first part, which is a general introduction about robotics, I mean, to ask them, to give them examples, to show them videos about what is robotics. Because I believe that students right now believe that robotics is only this human being that they see in movies. But they don't understand that a robot can be used in industry, in agronomy, in medical operation, in services, in education, and so on. So the first part, and this is really very important. And we've did a PowerPoint presentation, and it is on our digital platform, where for each single lesson, from lesson 0 and above, we give you ideas about questions that you should lead. I will be showing you in a few minutes how to lead this chapter. And what I was saying, that the first part is to make this introduction to your students about robotics. I will go back to this part. The second part is how to make them understand the logic of programming a robot, and to understand how a sensor is programmed and how it will react, and the motor and the behavior of the robot, the motor or the brake. Okay, and this is mainly, we don't need a hardware robot in our hand. And the third part of the robotic teaching journey or process is to understand the hardware in case you have it, in order to start making what we call to build and to unbuild the robot. But here, let me be clear that during the ICT lessons that are like 40 to 50 minutes, okay, we believe that even students are in class, and even if they have their own robot, okay, they cannot do this building and construction, since they need more time for that. I will be excused for just 1 minute. I will be back. Excuse me. So I repeat, teaching robotics is divided into 3 parts. The general part was the environment of the robotic world. The second part is to develop skills in programming, and what we can do here on this virtual robot that we can see on the screen. And the third part is to build and unbuild robot, which is clearly impossible in a classroom or in ICT. If you have, for example, let's say a robotics club in the afternoon, where students can stay for 2 hours, and you have, let's say, 10 students, okay, you can do it, no problem, since they have time. But in class, somebody is asking me, like, a simulation program where the robot can respond to the code. Yes, Mrs. Bayan, this is what we are doing right now, where the robot will respond. You will see that the robot will not move, but it will react to the commands that we can give simply by making those programming. So I will try to find the PowerPoint presentation. Can you give me just 1 second to see on my okay, robotics. Okay. Did I send you this document before, the robotics guide for grade 4 to 6? It's on the platform. You can download it, no problem.
It's in the Dropbox, this one?
It's on the digital platform. Yes, you can download.
Okay.
Okay.
Yeah.
So I was saying that why our choice is for Lego, simply because behind it, behind Lego Education, which is the company, there is a wide range of educational product. It's adopted by many Ministry of Education in many countries, leading to robotics competitions like the first Lego League and WRO. And this is the most important thing, that it's compatible with Scratch, Make Code, Small Basic, and Python. So the idea is not to buy or not to adopt any kind of robot from the market without, we can find robots on the market, and maybe it's not expensive or it's cheaper than the EV3, but believe me, you will not have this educational solution, since this robot specially can cover all the grades from grade 4 till university studies. What we can change is the mission and the level of difficulties in the missions. After that, when you know that you can program this robot using Scratch, Make Code for Microsoft, Small Basic, and Python, we believe that this is an added value for that. And if you are teaching for the first time robotics for grade 4, 5, 6, hear me and just memorize this remark, that the same introduction should be the same, like for grade 1, for grade 4. And how it should be leaded, look here, we've started with session 0, session 1, and so on. So in session 0, what we mean by session 0, we mean that before starting this chapter, okay, you can ask your students at home to make you a simple PowerPoint presentation alone or with their parents to explain you. Just 1 second, please. I have a problem in electricity. Sorry, I have to end this presentation since I have a problem with my generator. In Lebanon, we are suffering from electricity, as you know, maybe. So I promise for the 30 minutes, I will be conducting this. I will register this part. And if you have questions, we will be doing it later on. Is it okay with you?
Okay, thank you for your time.
I have to apologize, believe me, and I will be doing it. I will record a session for this remaining part. Okay.
Yeah, you can record the lesson and you can send the link, so we will watch.
Yes, for sure.
If we have any question, we can ask you on WhatsApp.
Of course.
Is it okay for you? Yeah.
Of course. Thank you very much, because my internet will cut now in few seconds.